Welcome to the last day of KVM Forum. My name's Alex Bennée. I work for Linaro. I mostly work on QEMU's TCG, so that's emulation side, but I have been known to do a bit of KVM in the past. So, first things first. Happy birthday, QEMU. 15 years old this year. So I thought I'd start this talk by having a little bit of a recap of how we got to where we are. So this is the 0.1 release notes that Fabrice set out. And the interesting thing to note here is his original aim for QEMU was to be able to run Wine binaries, Windows binaries with Wine on non-x86 platforms. A goal that I think everyone can agree that we've achieved. So some early milestones. QEMU was developed collaboratively very early on. So in April 2003, it went on to Savannah, which is GNU's hosting infrastructure. It's moved on since. There were the initial bits of system emulation were in by June, although this was x86 only. By April 2005, it was possible to do cross-compilation using Linux user mode, and it's still something that's done quite often with QEMU today. And by May 2006, you were starting to see things like the early ARM system emulation and additional architectures like MIPS being added. Interestingly, one of the interesting artifacts of the way QEMU initially did its emulation, it was a lot easier to add new backends, so new hosts that you could run QEMU on, than it was to add new front ends. If we have a look at the commit history over that time, I think you can see some of the major inflection points. So there's 0.1 back in January. And then KVM got merged into the kernel in February 2007. But when KVM was first merged into the kernel, the support for it was in a fork of QEMU called QEMU KVM. But by the time we got to 1.3 in December 2012, all the KVM support had been finally merged back up into the mainline repository. And then another point of note, when Peter took over as maintainer at the tail end of 2014. So in that time, 1.3 million lines of code have been written, although I'm fairly sure more has been added and deleted in the meantime. Almost 65,000 commits and 1,500 contributors. If you plug those numbers into these software estimate models, that reckons about 400 person years of development effort and about $50 million of investment to write that code. So let's have a look at what we've done this development cycle. So in the last year, almost 7,000 commits. Only about 8% of those are unreviewed. And when I say unreviewed, I counted commits that only had a single signed off by the author as unreviewed. Anything reviewed by, tested by, counted as reviewed for me. 600 merges, or over 600 merges. Of the 123 maintainers listed in the maintainers file, 77 of them authored commits in the cycle, and 350 authors overall. If we have a look at some of the growth areas in the code, hopefully you can see that. Biggest growth area is the hardware directory. So this is where all the device emulation, system emulation device code goes. Then we have target, which is where all the architecture-specific support goes in. So this is both for translation and for things like KVM support for individual architectures. And in fact, some of the hypervisors for x86 only also went in there. And then you include always gets touched. Whenever there's something that affects something across QEMU, you're going to see header files being added. Gratifyingly for me, test is also quite high up on the list. And then it all starts to tail off into the noise. Block drivers, Linux user, and then it all drops off. LAUNCHPAD bugs. We had 177 new bugs raised this year. We've got about 500 or 600 bugs in total in the system. It's a bit tricky for me to figure out what's going on with them because most of them seem to sit at the new status. If you look at the number of users affected and the number of comments, we've got a very large chunk of bugs that have basically been raised by one person going, this is a problem for me, no one else has commented, and it seems to have stuck there forever. I think part of this is because people raising bugs don't seem to read how to report a bug, so a lot of these bugs are missing important details like what version of QEMU they were testing, what command line they were using to run it, and stuff like that. CVEs, 25 CVEs this year. It doesn't seem super great, but compared to 2016 when we had 90, and last year when we had 65, it definitely seems to be going in the right direction. A balance of local and remote exploits, but generally the picture seems to be getting better. Feature releases, we seem to be sticking to a steady 3 release a year release cadence. All things being equal, I expect 3.1 should be ready by the end of this December. As well as the feature releases, we have our stable releases. I don't know how much people actually use this, but I know the distributions certainly appreciate having dot releases so they don't have to upgrade to a new major version of QEMU. So I think it's time we look at what we've been working on. So I generated this word cloud by looking at the title of the commits in the last year and removing all the boring words. And as you can see, the thing we seem to spend most of our time doing is fixing stuff. But you can also see some of the other major areas, so block migration, the architecture's PowerPC ARM, tests again, well mentioned. So it just gives you an idea of the sort of areas that we're working on. So what sort of features have we been adding to QEMU? So hardware-assisted virtualization. Traditionally, we all think of QEMU as using KVM. And the last development cycle, we also added support for Intel's HAXM. This year, we've now got support for the hypervisor framework, which is the MacOS hardware virtualization layer, and the Windows hypervisor platform, or basically what Azure uses. Right, the ghost in the room. You'd have had to been living under a rock if you hadn't come across Spectre last year. There's been quite a lot of Spectre across, quite a lot of work on Spectre across the whole stack, and I know support has gone into KVM and into all the tool chains. From QEMU's point of view, it was mostly a case of making sure we report the correct CPU ID and feature bits up to the guests so they can enable their mitigations. Okay, some new devices, RDMA, which is a remote RAM solution. We've got EDID support, which allows us to report information about monitors to the guests so they can properly size their displays. And features like SMMU, which is a IOMMU for ARM, so we're up to version 3 now on that. Right, TCG emulation. The big one this year was RISC-V. So RISC-V takes QEMU up to, I think, 21 guest architectures that we now support in our emulation engine. A more minor one, AArch64 big endian support, which I guess some people use, probably networking people. Internals, multi-threaded TCG. So this was a feature that we mentioned last year, but it was initially only enabled on a couple of architectures, and we've been slowly backfilling the guests that we support. RISC-V actually came with multi-threaded TCG already enabled because they were using the modern atomic primitives. But this year, PA RISC, in case anyone wants to use that, x86, S390, and Extensor all had multi-threaded TCG turned on. But we've not stood still there. There's also been continuing work to increase our scalability in emulation. And the big one this year was multi-threaded translation. So originally, even in a multi-threaded TCG setup, translation was a serializing point. Now it's fully multi-threaded. Another big chunk of work, soft float. As we were adding support for additional guests that needed half-precision floating point, which wasn't supported by our original soft float, we had to decide how we were going to approach this. So the next version of soft float upstream had added this, but it would have involved quite a lot of churn to bring that in. We considered backporting the changes from the next version of soft float into ours. In the end, we took a different path. We decided that it's time to fully own our soft float implementation. So it was a large refactoring effort. And now we've got a common code path for half precision, single precision, and double precision floating point. So there's still some work to do there for 80-bit and upcoming 128-bit floating point, but at least the code is a lot more readable now. I also mentioned decode tree. This was something that was written for ARM's SVE implementation, and it's a way of doing a data-driven generation of the decoder for translation, so you can get all the boilerplate for like extracting fields and that sort of thing done automatically from a data table and sanitized, and that's stuff that's easy to get wrong by hand, but good for a tool, and then you can just concentrate on the translation. System models. RISC-V, again, came with a whole bunch of system models. Sci5U is one of their dev boards. Spike is the BSD emulator. And then they also introduced a virt machine, which is very much like the ARM virt machine, is a completely virtual. You use virt.io devices. But if you just want to play with the instruction set architecture and you're not particularly interested in a particular hardware device, it's a good platform to use. We had Raspberry Pi 2 support in last year. This year, we've now got models for Raspberry Pi 3, and a couple of other dev boards have been added. Microcontrollers. I thought I'd mention microcontrollers separately because there's been a bit of a renaissance in wanting to support these very low-power chips. So the BBC Microbit was a device invented by the BBC to help in education. So it's a low-powered device that kids can program with Python. The MPS2 board is a modern microcontroller board that's trust zone aware, so you can play with the new features of modern ARM chips for IoT type applications. And then Sci5 also have their E platform, which is their embedded platform. I should also mention all the stuff that's been done by our outreach students. So every year, the QEMU project gets involved in various outreach activities. So this year, we had 4 Google Summer of Code and 1 outreachy student. And you can see what they worked on. So Julia and Stefan on the microbit, Shubham on Patchu, Emmanuel on the Qtest driver framework, and Nathan working on the vulcanizing Virgil. I should say that if any teams are looking to expand with junior engineers, you would do a lot worse than looking at the people that have already proved their worth in outreach. So, testing, area close to my heart. Enable sanitizers was added to configure. So this basically allows you to build QEMU with all the common sanitizers enabled. So things like address sanitization, undefined behavior. So if you're having trouble debugging a problem, enable sanitizers might be able to point you to where the problem is. We're starting to see avocado tests added to the QEMU source tree. So avocado's been in use for some time outside of the source tree for doing validation testing and making sure you can do installs and go through guided installs of the system. And we're now starting to see this inside QEMU. TCG tests. The TCG tests languished for a while because not a lot of people have working cross-compilers on their system, or if people want to set them up, sometimes it can be a bit of a pain. Now we leverage our Docker infrastructure to allow us to compile test cases for all the foreign architectures, so you no longer have to worry about having a cross-compiler. And finally, the QEMU synchronization profiler. So as we live in a more and more multi-threaded world and we're looking at more and more scalability, this is a good view to see where bottlenecks are in the code base and what's causing latencies. Last year, we started official deprecation policy. So some of the things that deprecated this year, GTK 2 in favor of 3, SDR1 in favor of 2. We dropped support for building on AIX. And we also got rid of the backends for Itanium and PA RISC. I mean, the PA RISC, we've probably got faster hardware and emulation anyway. Okay, finally, the bit that everyone wants, top trumps. So, of course, I'm referring to the card game here, where bigger numbers are better, so nothing orange-related. Okay, this is the author breakdown. I ran these numbers last week, and we had a dead heat at the top, so I had to rerun them yesterday. And Richard has just taken the crown as the top author this year, followed by Peter. Philippe, who's a relatively new member of our community, has also been doing sterling work. And then Marcus and Kevin. So a round of applause for our authors, please. I just thought I'd show you this graph that I wanted to get some sort of idea of what our development mix was. So this graph, I'm plotting experience. So this is how many days since your first commit went into QEMU on the x-axis, and your project total. I'll leave you to guess who that top right-hand corner person is. But I think on the size of the circles is the number of commits that went in this development cycle. So I think that what this is showing is we have a relatively broad development community, and people of all levels of experience are able to make significant contributions to QEMU. Right. Last bit, reviewers. Reviewers, super important. We rely on reviewers to catch bugs at code review time. And This year, Philippe tops the charts, and then followed by Eric, Richard, Peter, and Thomas. So let's have another round of applause for our reviewers. And finally, because we're really tight on time, the tested by is just a useful way. If you've got access to hardware that developers don't have access to, it's a good way of showing that you have run their patch set on interesting hardware. So, yes, there's our testers. Okay, thank you very much. You can find me on social media. And with that, I think we're ready to hand over to the next talk.